3D printing today is being used to make end-use sellable products. And it stands to cause a huge paradigm shift in how products are made all over the world. My name is Adam from PowerBelt 3D, and last weekend I attended the East Coast RepRap Festival. If you're a fan of 3D printing, I highly recommend it. It was all of the popular brands, names, and faces all under one roof, ready to connect and collaborate, and it's a lot of fun. I got to meet some people that I had only previously met over the internet. I got to show off the Ender Easy Belt project in person and see people's reactions to it. And for the first time, we sold products, Formula 32 conveyor belts, and belt printer nozzles in person. So I learned a lot. It was a lot of fun. It was also very tiring. But overall, it was an awesome experience. If you haven't been there, I can highly recommend attending in the future. Another thing I got to do last weekend was I got to present in front of a live audience. I actually kicked off the speaker series for the weekend at noon on Saturday. There were a lot of great talks and panels that I didn't get to see a lot of because I was working at our booth, but I will make sure to link it in the description of this video. It was live streamed over on the East Coast RepRap YouTube channel. So head over there once you're done with this video to check out all of the good speakers and information. I really enjoyed preparing and giving this talk because I was able to really speak to why I'm so excited about 3D printing, especially lower cost 3D printing coupled with automation, and how we can use that to create products and solve problems and make the world a better place. Make sure you stick around to the end of the video to get the full scope of everything that I'm talking about. And if you get to the end and you like this video, feel free to like and subscribe, all the normal YouTube stuff. But anyway, I wanted to post this here for all of you that have been following for a while. Let's get started. Hello, everyone. Thank you for joining me this afternoon. I'm very excited to be able to kick off our awesome set of speakers on the Build platform. Can I get a show of hands? Is it anyone's first East Coast RepRap Festival? Oh my gosh, almost the entire room. That's incredible. It's been since 2019 that we've been able to have this event. I was lucky enough to be there just a few years ago. I wasn't speaking then. I have prepared a very full presentation for you all today, so I think I'm going to use all of my time. If I don't, I'm happy to take questions at the end. If not, you're welcome to stop by the PowerBelt 3D booth, which is exactly on the other side of this curtain, and I'm happy to answer any questions that you have over the weekend. The other question for you guys, I wanted to gauge kind of how experienced we are in 3D printing. Has anyone been printing 1 year or less? Can I get a show of hands? 1 year? Okay, we've got a couple. What about less than 5 years? Once, okay, maybe half of our audience. And then 10 years, between 5 and 10 years. Okay, about another half of the room. That's awesome. So for some of the more experienced ones in the audience, you might notice a lot of common themes that you've heard before, but I also tried to sprinkle in some of my independent research and a lot of data, so hopefully you can still have some good takeaways. I wanted to start with some thank yous right at the top, and I wanted to thank my beautiful wife, Kristen. Here you can see myself and Kristen with our cat, Mia. Mia keeps me on task during the day, and my wife is kind and loving and infinitely supportive, almost to like a weird amount. Like, we were living in a one-bedroom apartment, and I had 3 3D printers just in our living room. I'm really not sure how I got away with that, but everything I'm working on really wouldn't be possible without her. I also wanted to say thank you to a few different movements that have been going on really since 2012. So much of what I'm prepared to talk about today would not be possible without the lowering in cost of 3D printers.
So since the core FDM patent expired, the RepRap project, open source ideology, and low-cost microcontrollers have been able to lower the cost from tens or hundreds of thousands of dollars to just a few $100, which is really the backbone of everything that I'm talking about. So much of what I think is possible for the future of plastics manufacturing is due to these movements. So if you've contributed, I wanted to say thank you. And I also wanted to thank all of you. There's so much cool stuff to see in this building today and this weekend, so I wanted to say thank you up front for spending some of your time with me. My name is Adam Fosnot. I am a mechanical engineer. I've been 3D printing for over 9 years with printers from under $200 to well over $200,000, from plywood kits to 3D printers that make aerospace components. And I love pizza. And naturally, that doesn't make me particularly unique or special, because who doesn't like pizza? But I've actually been making it from scratch almost every single week for over 5 years now. I've loved it since I was a kid, and it's been a fun thing to get into. I'm also very excited about solving the automation problem within 3D printing and all of the good that that could do, that I'll get into towards the end of the presentation. And 3D printing is a lot of things to a lot of different people. 3D printing is fun. You can make desk toys and almost any Pokemon figurine you can imagine, which is pretty incredible. 3D printing is also kind of silly. Nope, I am ahead of myself. The first time I saw a Kirby with legs, I was equally amused and confused why that would ever exist. But it brings people joy, and that's a great thing. For some people, 3D printing is purely educational. They learn about it in school, and then they move on to do something with the rest of their lives. For some people, it's a tool that helps them do their job better, whether in an engineering setting or otherwise. And like a lot of us in the room today, 3D printing can be a hobby. It's fun to learn and tinker and modify things and get a lot of joy out of that. But 3D printing is also a revolution, particularly a revolution in the sense of plastics manufacturing. And I imagine many people roll their eyes when they hear the word manufacturing. It's not exactly the most interesting topic. It's often associated with dirty warehouses, but it's also incredibly important. After all, we all have stuff. We all have toys, electronics, thermometers, bicycles, and 3D printing, while it has its drawbacks at times, is actually a really good way to make stuff. And I believe that 3D printing will one day become the dominant method of making plastic parts. And I'm sure it'll affect metals, electronics, and more. But the reason I'm really so convinced about the plastic side of manufacturing is because it's already happening today. But before we get to that, we have to look at how plastic components are more traditionally manufactured. There are a lot of ways to form plastic. You have blow molding for things like plastic bottles, or thermoforming for things like bubble shell packaging. And they all have their place depending on your specific application, but none is really more prevalent and popular than injection molding. I did a little bit of digging, and I found that the very first instance of mold making dates all the way back to ancient Greece in the 4th and 5th century BC. And I'm sure at the time it was absolutely incredible. You know, all of a sudden you didn't have to carve every single piece by hand. If you wanted multiple pieces of the same item, you now had a tool that let you more easily do that. And since then, molds have been used for clays and metals and lots of different cultures over time. But plastics weren't actually molded, injection molded, until 1872, when the very first injection mold was patented. A short 74 years later, some substantial improvements were made, and because this was around the time of World War II, this drastically accelerated the adoption of injection molding, because the US was looking for any opportunity to make parts cheaply and quickly. And if you fast forward to today, injection molding is a big deal. It's estimated to be worth over a $270 billion market. It's used for all sorts of products all over the world. If you're not familiar, injection molding works something like this. In its simplest form, you have two halves of a mold. They get clamped together, plastic is injected, the mold comes apart, and then ejector pins release the part from the mold. This happens over and over and over again to create, like I said, tons of different products. But that doesn't mean that it doesn't have its drawbacks. And one that some of you may not be aware of is that one of the key drawbacks is lead time. When you're trying to make an injection molded part, it's very common to have to wait 4 to 12 weeks to have your injection mold actually made. And then once that happens, you hope that the parts are correct, because if you need to make any changes to that injection mold, you're out more money and a lot more time to have any of those parts made. Injection molding is also inflexible for that reason. So once you wait that time, like I said, more time and money to have any changes made. You really can't iterate cycle by cycle as easily as maybe 3D printing could do. And then maybe the most popular disadvantage of injection molding is cost. I looked up one injection molding company published that on average an injection mold that they would make would cost $12,000. And for all these reasons, unless you're ready to commit to tens or hundreds of thousands of parts, injection molding just doesn't make sense. But when you compare that to 3D printing as it stands today, it actually solves for the main three issues with injection molding. 3D printers aren't expensive anymore. You can get a 3D printer for under $200. You can set it up and have it running in a few hours. Lead time, all of a sudden, isn't as much of an issue. You can choose from any number of brands on Amazon and have it delivered quickly and start making your parts. And they're also infinitely flexible. You can be making Baby Yodas in the morning, whistles in the afternoon, and face shields in the evening if you want to. And that flexibility really applies to making hardware products because, again, you don't have to commit to 100,000 parts and hope that they're right. Instead, by using 3D printing, you can iterate your product more often, similar to how software companies will push out updates on sometimes a weekly or monthly basis. Hardware companies can start to do the same thing. But that's really just the tip of the iceberg. Beyond that, when you buy an injection mold, it really only has value to your company. It's very unlikely that another business would ever want to buy that injection mold and start making the very same part that you are making. But 3D printers, on the other hand, become an asset for your business that have resale value once you're done with them or maybe want to upgrade them. You also have more design freedom, which is probably no secret to many people in the room. But with 3D printing, you can do things that you could never imagine being able to do with injection molding or casting or very similar traditional means. You also have less material waste. All of a sudden, you don't need to carve cavities out of metal and waste all of that material. Instead, you can just make the parts that you need without needing first to make tooling. But I'm not the only one that understands this, and maybe one of my favorite examples is Etsy shops. You can look up right now for 3D printed items on Etsy, and you will find dozens and dozens of people making and selling real 3D printed products. Now, they're not at the hundreds of thousands of units of scale, but it really doesn't have to be a legitimate business and prove, in a sense, that people will buy 3D printed products. One that you may or may not know of is called Voodoo Manufacturing. They operated out of Brooklyn for many years. Fortunately, they're out of business now, but I think there's a lot more that might have gone wrong there outside of the actual core technology. Another one is called Slant 3D out of Boise, Idaho. They operate several very large-scale 3D print farms. And of course, we can't mention print farming without mentioning Prusa, who is one of the more popular names in 3D print farming. And all of these businesses are choosing to use 3D printing to make end-use sellable parts, all without the limitations of injection molding. And I'm sure you're thinking, all right, if this is all so great and wonderful, why isn't it more widespread? Why aren't more people using it? And the first one of those challenges is education. People who design products are most commonly design or product engineers. And the current workforce engineers knows how to design for injection molding. It's what they've been using for years, and it's what they're used to. So on the surface, this seems like a huge challenge. How do we educate over 150,000 engineers in the United States alone, especially when people tend not to like change? But I believe this problem will actually solve itself over time. You see, kids today are learning about 3D printing in their classrooms, in their libraries, and they're not learning about injection molding or urethane casting. The next generation of engineers will understand 3D printing as the default method of making things. And then as they enter the workforce, they will solve problems using 3D printing that the current of engineers never would have imagined. And we know this because of a psychological principle that is known as the law of the hammer, also known as the law of the instrument, that says if the only tool that you have is a hammer, every problem looks like a nail. And this concept is widely attributed to Abraham Maslow, who you might recognize from a high school psychology course as the same guy that came up with Maslow's hierarchy of needs. So he's at least a little qualified to speak on this sort of thing. And ironically, this concept is in large part responsible for why the current generation of engineers doesn't choose 3D printing for their products. Instead, they're choosing a tool that they're familiar with traditional processes, as their tool of choice for tackling problems. Our next challenge is consumer fear. And I've met with lots of different injection molding companies and product designers over the years. And when you're designing a product, especially one for consumers, how it looks and feels is important to you. I think that there's a real fear that 3D printed products won't sell, and that's because for so long injection molding has been the default method of creating plastic products, and there's an expectation that parts are smooth. I would argue that a few slides back we saw lots of examples of 3D printing farms making and selling real products, and I think that's a good argument that people will buy them. I imagine some people might even pay more for a 3D printed product because they think the process and how it's made is cool. But more than anything, I imagine that the typical consumer never ever thinks about injection molding or urethane casting or sheet metal forming. That's more for nerds like us to think about the processes that go into all of the stuff that we use on a daily basis. And the last challenge that I see is automation. The vast majority of 3D printers, whether they're $200 or $500,000, aren't automated. And it's not a challenge that I see the industry leaders in 3D printing really trying to address. The constant need for human intervention to empty build trays is holding back larger scale adoption. And I think you could argue that if injection molding required a person to sit there and pull every part out of the injection mold, it never would have become the dominant way of making parts that it has. And this is the challenge that I'm most interested in, excited about solving. And I want to share that, but first I want to talk about some numbers as to, just to try to point us in the right direction of, is this actually a problem that needs solving? And over the years I've heard both a sentiment and a number thrown around that 3D printers cannot ever be used for larger scale production because they are only ever 80% uptime, 80% productive. You have to account for heat up and cool down and manually removing parts, but meanwhile, big business manufacturing, they're always aiming for 100% productivity, so it's not possible. But I wanted to do a good job with this presentation and not just give you a rule of thumb. So I fired up Prusa Slicer and Cura, and I analyzed what would happen if we were going to start a benchy factory, right? Everyone knows a benchy takes about 2 hours on most printers, and I loaded up full build trays, and I charted it out over the course of a full week, and I accounted for, like, maybe you have an intern to come in at 2 in the morning on Saturday, and maybe you don't have an intern, and I averaged out all of those uptime, productivity calculations, and what I discovered was it was about 77%, and that's obviously like an ideal situation with someone there as soon as every job finishes. That's not realistic, right? You're gonna have some play in there, so 80% is actually a pretty good number. And for me, it confirmed that if 3D printing is ever going to be used for more than just desk trinkets or prototypes or jigs and fixtures, that this is actually kind of an uphill battle. It would never make financial sense to buy an expensive injection mold and put it in every neighborhood where your product is needed. But if an injection mold were a little bit different, let's say it had the superpower of being able to make any item you could imagine and maybe make products for multiple companies at the same time as they were needed, it could suddenly make financial sense to put a 3D printer or a plastic production machine in every neighborhood where your product is needed. See, it's no secret that today products are only made in a few places. China makes a whole bunch, the United States makes a whole bunch, and if you add those two numbers together, that's 45% of all products across all categories are really only made in two places. And what happens when you make products in only two places, you get what we call supply chains, which is something that most of us had never given a second thought to until a few years ago. But the world could look a lot different if instead of making products in only two places, we started making products everywhere. Instead of building supply chains, we could make a web. We could make a world wide web of fully automated 3D printers. And that opens up a lot of room for thought of what would the world look like and what problems could we actually solve that aren't being solved today because they can't be made profitably. And I think that the more problems that we can solve, the better the human experience will be. So I'm an idea person. I have more ideas than ever I can possibly pursue myself, and I imagine a lot of other people in the audience are idea people. And when I started thinking about how many ideas never get made, how many problems don't get solved because it's too expensive to be made profitably, because truly that's the reality that we live in. If you can't make a return on investment to solve a problem, the problem just doesn't get solved. If a problem that a physical product could solve is just deemed too small to justify $100,000 of investment, it just doesn't get made. But low-cost 3D printers coupled with automation can let us solve those types of problems that are deemed too small. So what kind of world could we live in if we were able to solve smaller problems? Well, we could live in a world where anyone who wants a prosthetic can actually afford one. We could live in a world where people who have difficulty using their hands for basic tasks that most of us take for granted could have the tools available to do those on their own. And all of these products can be made more locally, which is actually really important and useful. The shipping industry is responsible for 1 billion metric tons of carbon dioxide being released into the atmosphere on a yearly basis. But if we could start making products closer to where they're actually used, we could make a massive step towards addressing climate change. And when times are good, this global network can focus on the good and making things better. And when times aren't quite as good, they can make what we need, where we need, and when we need it, having an even bigger impact. So, one day, I believe at least, 3D printing will be the dominant method of making plastic parts. It'll do that because it actually addresses the 3 main drawbacks to injection molding that exist in our current world. Excuse me. There are some challenges ahead. However, I think if you look at the first 2 of those challenges, those will go away naturally over time as the younger generation grows up with 3D printers, a lot like I grew up with computers versus just a generation before me that wasn't something that was possible. And I'm sure some of you are still skeptical. I'm skeptical, so I'm not here to judge. But really, if you look at every revolution in technology, a lot of times they can feel explosive and exciting, but that's not actually the case. They actually follow a very clearly outlined cycle called the Gardner hype cycle. They explode in popularity, dip down, and then build slowly and quietly in the background of our lives until you wake up one day and suddenly that technology is everywhere. You can look at the automobile to ebooks to video streaming to cryptocurrency. All of those technology innovations follow this same cycle. And if you need any evidence of this actually happening in 3D printing, I'd encourage you to look up the stock value history of the industry leaders in 3D printing from 2009 till now, and you'll see a curve that looks shockingly like this. So, for those of you that in the crowd that are less than skeptical, you probably want to engage with this massive paradigm shift in how products are made. And if you make products, you can just choose to 3D print them. It's really that simple. You just have to decide not to injection mold them and start getting all of the benefits available by 3D printing. There's probably going to be a bit of a learning curve. You might have to learn some new design principles. You might have to learn about some new plastics that maybe you aren't used to, but it's entirely possible. And if you are an engineer, I want to encourage you to try to solve problems with 3D printing. At a minimum, when a colleague wants to try to solve problems with 3D printing, allow them to do that. I want to challenge you to think outside of the way you've always done things and try to solve problems. I'm one slide ahead of myself. Okay, I had a credit slide in there to thank everyone where I borrowed information and pictures, but, you know, who needs that? I think I'm uniquely qualified in conveyor belts and automated 3D printing. I've been building them for almost 4 years now in lots of different ways. I'm open to collaborate on projects if you have a product that you want to make, or if you have a 3D printer that you wish was more automated, or if you're an engineer that regularly orders parts and you wish that that happened faster. I have some projects that haven't been announced publicly yet that I think could help with that. Oh, there it is. Anyway, like I said, I invite you to visit the PowerBelt 3D booth. We are right on the opposite side of that corner. Happy to chat, answer questions. If you have business inquiries, best place is my email address. Otherwise, I'm all over the internet at PowerBelts3D. Thank you.